Welcome back everyone to our channel Chemistry Made Simple for NEET, and this is Dr. Radha Subramaniam with you, and we will be continuing today with the remaining sessions of solid state chemistry. So already I have uploaded 2 sessions from this topic, and today we are going to do the third session. Hope you all have already watched those 2 sessions, because it's straight away taken from NCERT and I have made it very short and simple for you. So be sure that you don't miss this important sessions. Okay, before we move on to our session for today, let me answer a few questions I had received from a few students regarding NEET 2022. So the question is, what would be the what would the state of eligibility be if class 10 and class 12 both are studied in different states? Okay, it's not a matter of concern, because the candidates can apply to any state except Jammu and Kashmir for all India quota seats in NEET, but the best choice in this case would be to choose the state where the permanent address of the candidates is, or to go for the state where the applicant has complete domicile eligibility for 85% state quota seats. Okay, next question is, if after class 12 I have taken up the improvement exam, what year should I mention in my NEET application form? So for such students, they can enter the earliest year of passing if they have taken up an improvement exam to obtain good marks, and not because they didn't achieve success. So if it's not cleared and you are preparing to appear again for some subjects, then enter as appearing and select code 101 as the code of the qualifying exam. And another question is, by mistake, if I've made the payment twice for the application fee, will I get the excess back as refund? Yes, for that the fee that is not updated will be refunded in a matter of 7 working days. Okay, I think that is clear for you. Now let me move on to today's session. We will start with 2-dimensional packing. Okay, what is 2-dimensional packing? See, when rows are combined touching each other, you get the crystal plane. So the rows can be combined in 2 different ways. Like when the particles placed in adjacent rows, they show horizontal as well as vertical alignment and they form squares. Such type of packing is called square close packing. So it just looks like a square, and we call the first row as A type row, second row being the exactly same as the first one is also of A type, and we can also place more rows to obtain A type of arrangement. So in this arrangement, each sphere will be in contact with 4 of its neighbors. So the 2-dimensional coordination number will be 4, and if the centers of these 4 immediate neighboring spheres are joined, you get a square. So we call this square as square close packing in 2 dimensions. Okay, now see, the particles in the next row are placed in depressions between the particles of the first row. What is depression? You know, like a bend like hole like thing. So the particles in the third row will be vertically aligned with those in the first row. So this will give hexagonal pattern, and we call it hexagonal close packing. And you can also place the second row above the first one in a staggered manner, that its spheres fit in the depressions of the first row. So the arrangement of spheres in the first row is called A type, the one in the second row is different, and this can be called as B type. And when the third row is placed adjacent to the second in staggered manner, then these spheres are placed with those of the first layer, or alignment is with those of the first layer. So this layer is also of the A type, and such spheres of similarly placed fourth row will be aligned with second row B type. So we call it AB type, and these cases empty spaces are there, and they are called as voids. Clear? See here, the type A type, see, identically each row are placed one above the other. See, BA type, see, between 2B there is a depression, so we keep A here like that. See here, this is a square shape. Okay, see, centers of 4 neighboring spheres connected together, we get a square shape. Here see, adjacent centers, if you connect with each other, you get a hexagonal shape, that is BA. Clear? Hope it is clear for you. Now packing can be done in 3 ways, like 1 dimension, 2 dimension, or in 3 dimension. And close packing in 1 dimension. So there is only one way of arranging spheres in 1-dimensional close packed structures, and that is to arrange them in a row and see like this, touching each other. In this arrangement, each sphere is in contact with 2 of its neighbors. The number of nearest neighbors of a particle is called its coordination number. So here the coordination number for this case is 2. Why? Because number of nearest neighbors, see 1, 2 together. Okay. So because each sphere is in contact with, see this is in contact with this and this, like that, 2 will be the coordination number. Okay. And regarding 3-dimensional packing, these 3-dimensional close packing from 2-dimensional square close pack layers. So if you place the second square close pack above the first, and we follow the same rule which was followed when one row was placed adjacent to the other. The second layer is placed over the first layer, so that the spheres of the upper layer are exactly above the first layer. That already I showed that in here for you in the diagram. So the arrangement of spheres of both the layers are perfectly aligned horizontally as well as vertically. And if you place more layers one above the other, arrangement, the first layer we call it A type, and all the layers will be the same. So AAA lattice type pattern, and the lattice just generated, we call it simple cubic lattice, and this unit cell is a primitive cubic unit cell, cubic lattice, simple cubic lattice. Hope you get this point clear. Now 3-dimensional close packing from 2-dimensional hexagonal closed pack layers. So 3-dimensional closed pack structure can be generated by placing layers one over the another. See, it is placed one over another. So if you connect, see the centers of all the nearby spheres, you get like this square shape like this. Okay, next face centered cubic unit cell. See, you get lots of problems from this type, and after finishing this unit, in between also I will be uploading NEET based questions which have come from this. And FCC, face centered cubic unit cell, it contains atom at all the corners and at the center of all the faces. So all corners and center of the faces also. So this is FCC unit cell. 8 corners into 1/8 is 1 atom. So 6 face centered atoms will be there, and half atom per unit cell, because adjacent will be sharing. So that will be 6 into 1/2, that is 3 atoms. So total number will be 1 plus 3, 4 atoms for FCC, remember that. Now number of atoms in one unit cell. For primitive cubic unit cell, it has only 8 atoms in its corner. So each atom at corner is shared by 8 adjacent unit cells. So 4 unit cells in the same plane and 4 above or below the plane. That is how the sharing takes place. So that is why you take only 1/8 of an atom, because actually belongs to a particular unit cell, only 1/8. So each small sphere is represented only the vertex and not the actual size. We call such structures as open structures, and since each cubic unit cell has 8 atoms on its corners, the total number of atoms in one unit cell is, see here already I have shown here for this diagram, it is 1. I have shown you the calculation also. Okay. Now you can see different types over here. See, first one is cubic. Okay, for cubic cell, first one, see 90 degree. Okay, angle. So alpha, beta, gamma, see all corners are 90 degree. For tetragonal, see this is 90, this is 90, this is 90. Look at the shape. Then orthorhombic. So corners are all 90 degree. Hexagonal shape is this. Rhombohedral, monoclinic and triclinic. Okay, see here I have shown you with the alphabets, and see B is equal to A and C is equal to A, like A, B, C monoclinic and triclinic A, B, C. Look at the shapes of this and where the angles are formed. Okay, take a screenshot of it and you can observe this angle formation and all. See, for the first 3, see all same here, back side and top. See, same. See, but for here, see this is 120 degree for hexagonal, and this is 90. Gamma is 120, alpha is 90 and beta is 90. Okay. For monoclinic also A, B, C, alpha, beta, gamma all are 90 degree. Okay. Now what are the types of centered unit cells? Body centered, BCC, face centered, FCC and end centered unit cell. For body centered unit cell, each unit cell contains one constituent particle at its body center besides the ones that are at its corners, and free centered contains one particle present at the center of each face in addition to the one present at its corners, and end centered one constituent is present at the center of any two opposite faces besides the one present at its corners. Okay, placing the second layer of the first layer. See, the sphere of the second layer is above the void of the first layer, like this. See here. And these voids are called tetrahedral voids. See here. okay, because a tetrahedron is formed when the centers of these 4 spheres, if you join them, and they have been marked by T in the figure, if you can see it. I hope, see, I have taken a lot of pains to make this graphical representation for you using figures and all that, and some of you had asked me why I am not opening my comment section, because you see lots of distractions are coming through comments, and I have watched students talking with each other and unnecessarily wasting time and having arguments over the page and all that. So I don't prefer distraction at this stage, because your exams are nearing. So actually whatever have come for previous years and whatever are required for the exams, have included all those topics, because I have been in this field for many years, and also I take into consideration the requirements of the students, and I try to include a maximum possible whatever is required for your exam sake. So I don't please don't misunderstand why comment sections are off, and I'm also getting good encouragement and support from many students who know me personally as well. And I hope all of you, even though I don't see any of you, or I don't know who are watching this, but in future I'll be surely opening my comments page once your exams are over. Okay, next. So at other places, triangular voids in the second layer are above the triangular voids in the first layer, and the shapes of these do not overlap. One of them has apex of the triangle pointing upwards, and other will be downwards. So it is marked as O. So these voids are surrounded by 6 spheres, and they are called octahedral voids. And the number of these two types of voids depend on number of closed packed spheres. Suppose the number of closed packed spheres be n. So number of octahedral voids generated also would be n, and but the number of tetrahedral voids generated will be 2n. And remember this relation as well. And with that we are coming to a conclusion of this session of solid state part 3. I'll be uploading 4 more parts of this session, because this is quite lengthy, and so I cannot hurry you up and keeping so many things in your mind in one session. So I'm splitting this for your sake, and already I've done all the difficult chapters also. So this one is very important, so that is why we are doing this right now. And always, as I say, please do like, share and subscribe to my channel. Share it with your friends so that they can also benefit from these NCERT lesson based concepts. And also don't forget to press the bell icon so that you get notifications immediately as soon as I upload the video. And please do continue supporting our channel, and we don't charge any fees to any of the students, and in future also I plan this channel to be completely free of cost, and the contents would be coming free of cost for you. So please support our channel, and with that we are winding up for today. Thank you for watching the video.